Good morning. Hope you're doing well. Before we get started, I wanted to share with you an update on your friend Phyllis. I know you see Phyllis and JoJo in all of your, or many of your examples and problems. And so I just wanted to show you a couple pictures. So Phyllis had, about a year ago, when we were in Sheridan, she had ACL replacement surgery, TPLO surgery at Mountain View on her right back leg. And Dr. Pete said in about a year her left leg would go out. Well, sure enough, about 2 weeks ago, she started hopping around the house and her left ACL was torn. So we took her in for ACL surgery, and she's doing great. So here she is after surgery with her floppy cone on, and you can see her bandage. And so then it's very interesting in Tulsa. They have a rehab center that does canine rehab and acupuncture. So you can see Phyllis in her doggles, and I think this is very exciting. They do a laser therapy on her back hip and her back knee, just to heat it up, I guess. You guys in agribusiness probably know more than I do. But they run this laser up and down to heat her leg, and so when you're in the room, you have to wear these glasses so the laser won't get in your eyes, and Phyllis has to wear some doggles. So thought that was pretty fun. Wanted to share that with you. So this week we're going to talk about planning for capital investments. And this is an interesting lecture. It mixes a little bit of math, a little bit of finance, and a little bit of economics. And what I think is really important to note that I didn't note when I was in college is we're going to talk about the net present value method and the internal rate of return method. And these are two methods for determining if a project is worth pursuing, if it's going to return an acceptable rate of return to the company. If you will remember net present value method and internal rate of return method, you'll be miles ahead when you get out there in your careers. You will often see finance positions posted looking for folks to do net present value and internal rate of return calculations when they're looking at forecasting, finance development jobs. So I think that NPV and IRR are very important. So we're going to talk about those today. We're also going to talk about the cash payback technique, the profitability index, and a little bit about capital budgeting. So let's dive in. What is capital budgeting? Capital budgeting is the process where a business determines and evaluates potential large expenses or investments. And remember a couple weeks ago when we talked about budgeting and we went through the operational budgets and the finance budget. We went through the operational budgets and the finance budgets. We said there's also capital expenses, CapEx. Well, that's capital budgeting. So this might be things like building a new plant, investing in a long-term joint venture, and larger purchases of fixed assets. Probably not vehicles, but maybe a fleet of vehicles, or when you're talking about buildings. So those larger expenses, that's what capital budgeting is. And a capital budgeting authorization process is going to look different from firm to firm, but there's going to be 4 consistent points. The titles might change, but the points are going to be the same. And the first is that project proposals will be requested from departments, plants, personnel, right? Again, this is that participative budgeting. Everybody's giving their input. What do those departments propose that would help them in terms of, whether it's machinery for production, whether it's fleet vehicles, whatever that might be. What do those departments think they need? So the project proposals are requested. Next, proposals are screened by a capital budget committee. There's almost always a budget committee. For example, at Sheridan College, this is the VPs and the AVPs, but it might be whomever. Next, officers determine which projects are worthy of funding. This might be the president and the CFO. This might be a finance committee. But there'll be a set of executives who determine what projects are worthy of being funded. And then lastly, the board of directors will approve the capital budget. So it's sort of this pyramid, right? These departments make their requests, a committee screens the requests. Those decisions then roll up to the officers or executive team who determine which projects will get funded, and then the board of directors will have that final sign-off. So that's the capital budget authorization process in a nutshell. So when we talk about capital budgeting, we use estimated cash inflows and outflows as our inputs. And this makes sense, right? Because ultimately the value of any investment that we make is going to be determined by the value of cash flows that we receive, and it's going to be reduced by the value of the cash flows that we have to pay out. So cash flows is the basis for capital budgeting, And the decisions that we make are going to depend on these 4 points here: availability of funds, relationships among proposed projects, a company's basic decision-making approach, and the risk associated with a particular project, right? So funds availability, how the projects are related to one another, our fundamental decision-making philosophies, and then we have to acknowledge any of the risk that's inherent in any of these projects. So those are what the decisions are based on, and then those are based on cash outflows and inflows. And you see some examples of those over on the right. Outflows are obviously the investment, the repair and maintenance. Inflows are sale of any old equipment, any salvage value, any increased sales. So when we go through and we look at capital budgeting, we're going to look at cash inflows and outflows. And we're going to use this example through the chapter. We're going to use JoJo's Journey Shipping Company. And JoJo is thinking about investing $130,000 in new equipment. The equipment will have a 10-year useful life. It'll have no salvage value. And we're going to have estimated annual cash flows of $200,000 cash inflows from customers and $176,000 in outflows for our operating costs. So we expect a net annual cash flow of $24,000. This is just here so you can have it as you go through the examples when you print it or when you're studying later, but these are the facts we'll use through most of the chapter. So let's look at some techniques on how we value capital budget decisions. And that's really what we're going to focus on in this lecture, is how do we make those decisions on whether we should pursue a project or not. And there's several different techniques. One of the simplest techniques is this cash payback technique. The cash payback technique identifies how long it will take us to recover the cost of the capital investment from the net annual cash flow inflow produced by the investment. So how long will it take us to get paid back? That's why it's the cash payback technique. And the shorter the payback period, the more attractive the investment, right? We always want to get our money back quicker. And so there's a simple formula. The cost of the capital investment, so the cost of the project, divided by the net annual cash flow is the cash payback period. So for example, when we think about JoJo's decision, if he wants to buy this equipment that's $130,000, and there's a net annual cash flow of $24,000, then we would get paid back in 5.42 years, right? $130,000 divided by $24,000, 5.42 years. The shortcoming of this formula is we're saying we have the same annual cash flow every year. Of course, that may or may not happen, right? So what about when we have uneven cash flows? In the case of uneven net annual cash flows, the payback period is when cumulative net cash flows equal the cost of the investment. And that makes sense too, right? Look at the example here. Phyllis Company proposes an investment in a new website that's going to cost her $300,000. Well, in year zero, right? This is year zero because this is when we're putting this money out there. We're spending this money. So at year zero, we make an investment of $300,000. Then we see our net annual cash flows every year and see how they're not even. It's $60,000 in year one, $90,000 in years 2 and 3. So if the cash flow is different every year, all we do is keep track of our cumulative net cash flow. And you see that in the column on the right, right? And cumulative, I think you know, but cumulative is just we keep adding, right? It's like a running sum. So $60,000 in year one plus our $90,000 in cash flows in year 2. Our cumulative cash flow is $150,000. Year 3, we make another $90,000. Our cumulative cash flow is $240,000, and so on. And you can see that we hit our cash payback period at 3.5 years, right? We need to recoup $300,000. That's the cost of the investment. And you can see that about the 3.5 year mark, our net annual cash flows are at about $300,000. So the cost of our investment equals our cumulative net cash flow. We're paid back. But cash payback should not be the only basis for the capital budgeting decision, as it ignores the expected profitability for the project. And that's one of the main takeaways from this slide. Cash payback alone is not sufficient to make a capital budgeting decision. People will do it, but you shouldn't. And so we're going to talk about 2 methods of analysis that are called discounted cash flow methods. And that's the net present value method and the internal rate of return method. And these 2 methods are generally considered the best approach because they consider the estimated total cash inflows and they acknowledge the time value of money, right? $1 is worth more now than $1 will be a year from now. Think about retirement. You're saving $100,000 for retirement today, and it'll probably buy myself a soda and a cup of coffee when it's time to retire. A dollar's worth more now than later. And so net present value and internal rate of return consider these factors in their models. And so these are the models you're usually going to see used, and we're going to talk about both of them in some detail. Net present value is the first one. Then the net present value method, cash inflows are discounted to their present value and compared with the capital outlay required by the investment, right? And I think you've had present value and future value in other classes, but if you haven't, the present value of a dollar is what a dollar is worth today, right? So if you're talking about 4 years out, that dollar is going to be less than that dollar is worth today. So we'll look at that in a minute. But cash inflows are discounted to their present value, and they're compared with the capital outlay. So how much does the investment cost us? And when we discount, we have to use an interest rate. The interest rate we're going to use is called the required minimum rate of return. This is what we have to make before we would consider this project. And the proposal is acceptable if our net present value is 0 or it's positive. And then the higher the net present value is, the more attractive the investment will be. When you do net present value, there are some assumptions. We assume that the cash flows are at the end of each year. We assume that the cash flows are going to immediately be reinvested in another project with a similar return. And we assume that we can predict with certainty what our cash flows are going to be, right? And I think these three assumptions make sense, but you need to know that they're there. And then the graphic on the left just summarizes the investment decision, right? Present value less capital investment is our net present value. If our net present value is 0 or positive, we accept. If it's negative, we reject. So we're going to look at an example of how we would do this, and then I'm going to talk a little bit about the discount factor. So net present value, if cash flows are equal, you can discount all your cash flows at once. So let's assume, like we did in the problem a moment ago, that JoJo's annual cash flows are $24,000, and that's even. His annual cash flow is $24,000 every year. So if the amount is uniform over the useful life of the asset, the $130,000 asset we're thinking about purchasing, which is a 10-year life, then we can compute the present value of the net annual cash flows. And so what you see here is a discount factor for 10 periods, and I'm going to talk to you about this discount factor. So 5.65022 is the discount factor. The present value of the net cash flow is $24,000, and this is our every year for 10 years we get this. So we multiply it by the discount factor of 5.65022, and we get a present value for our net cash flows of $135,605. Okay? And if you look, and we talk about 10 periods, and we get $24,000 a period, right? That equals $240,000 in future cash flows. But notice that the present value of those cash flows is only $135,605, right? It's about $115,000 less. And that's just due to the time value of money. And so this is why discounting is so important. So if we discount to the present value of $135,605, and then we subtract our capital investment of $130,000, you'll see that we have a net present value of $5,605. So we would accept this proposal because the net present value is greater than 0. The discount factor may be a little confusing to you if you haven't seen it before, so bear with me for a minute. If cash flows are not equal, then we need to go back and we need to discount each cash flow individually. So assume that JoJo expects the same total net cash flows of $240,000 over the life of the investment, but because of the market shifts, the market demands for new products, the net annual cash flows are higher in the earlier years, they're lower in the later years, and most of the time you're going to see uneven cash flows. So you'll see in this column, assume net annual cash flows, right? It equals the $240,000, but they vary every year. So in year 1, your annual cash flow is $34,000. In year 10, your annual cash flow is only $18,000, right? So what you do is you discount each year by your discount factor. So the discount factor for 12% is shown here, And again, bear with me, I'm going to tell you where that comes from. But here's your discount factor for each year at 12%. You take your annual cash, so like let's look at year 6 here, right? You take your annual cash flow, so $22,000, times your discount factor. So for example, here it's 0.050663. So 22,000 times 0.50663 is $11,146. That's the net present value of your year 6 cash flows. And you do that for each year, you add them up. Okay, so $144,367. Take that, you subtract your capital investment, and there's your net present value. And notice now, if we look at uneven cash flows, our net present value is $14,367. It's greater than 0, so we would accept. So let's talk about discount rate. So a company generally uses a required rate of return that's equal to its cost of capital, right? You need to make sure that you pull in enough money through your project that you're not going to operate at a loss. So the cost of capital is what it costs you to obtain those funds from creditors or stockholders, right? This might be an interest rate. You'll also see sometimes the discount rate called the required rate of return, the hurdle rate, the cutoff rate. And then you also need to take that rate, that cost of capital, and you need to adjust it for any risk. So, if there's a risk in the project that you might lose money, you might want a higher cost of capital. So if you look at this table, you'll see present values for different discount rates, 12% and 15%. So looking at this same project, right, net cash flows of $24,000 a year, in the left column at 12%, we have a positive net present value of $5,600. We would accept the project because it's greater than 0. But maybe we have some risk. Maybe we need to get 15%. Maybe that's our required rate of return. Well, if we look at that 15%, our discount factor is different, right? And therefore, when we do our calculation, we have a negative net present value of $9,550. So in this case, we would reject the project. So obviously, the discount rate is pretty important. It can make or break an investment decision. And so what we keep seeing is this discount factor, which helps us get to the present value of money. I'm going to point you to a resource I hardly ever do. I'm going to point you to your book. There is an Appendix A in the back of your book, and it has all these crazy tables, right? And you can look at these crazy tables for discount rates. So as I mentioned in your book, there's Appendix A, which is, here's a page from it. I don't know if you can see it, but this is on page A10. This is table 4. And this is present value of an annuity at $1. And this gives you the numbers you need. So, for example, we see a discount factor for 10 periods at 12%. 10 periods at 12%. If we go to the row with 10 on it, and we go over to 12%, we can see that the present value discount factor is 5.65022. And that's where that number comes from. So you can do it using these tables. However, I would really discourage you from doing that. So I'm going to show you now how you can calculate it yourself and how you can calculate it using Microsoft Excel. And I would strongly, or Google Sheets, I would strongly encourage you to do it that way. You're usually not going to have a present value table around when you want one. You can Google one, you can do it that way, but I think as you progress through your career, and really even as you progress through this course, I would encourage you to do it. Just do it in Excel or Google Sheets. That's what I do. So here is the math, and there are 2 slides of math, and you can just close your eyes and scream if this looks crazy to you, but it's pretty straightforward. So here's how you calculate the discount factor. And the discount factor is the time value of money for a certain cash flow, right? Here's the formula. 1 over 1 plus I raised to the nth power. So this I is your interest rate, and this is in a decimal form, right? And then this n is the number of years in the future. And if you just use this formula, you'll get the factor that you need. So look at this quick example. Assume that the capital investment has an estimated life of 10 years, right? And assume that we require a 12% rate of return. What would the discount factor be for year 8? And this is just a random year, right? Year 8. So we know then that I is 12% and N is 8. And one thing to be careful of is make sure you don't put 12. Remember, we changed the percent to a decimal, so it's 0.12. But here's all you do. You take 1 over 1 plus, this is I, 0.12. This is N, 8. So 1.12 to the 8th power. So 1 over 1.12 to the 8th power. Well, 1.12 to the 8th power is 2.47596. 1 divided by 2.47596 is 0.40388. So for the year 8 cash flow, the discount factor at 12% would be 0.40388. Okay? And if we go back to the problem with uneven cash flows and we look at year 8, we'll see that the discount factor for year 8 at 12% is 0.40388. So we did our math correctly. Okay? So that's the way you can calculate a discount factor mathematically. It's good to know how to do this. So what if we're looking at equal cash flows where we just can apply that one present value for 10 years, right? So using the other one, we would have to calculate a discount factor every year. That was a discount factor for year 8. We'd need to calculate a different discount factor for year 9, and so on and so on. So if the cash flows are equal, we can calculate something that's called a cumulative discount factor. And the formula for the cumulative discount factor is a little more complicated. It's right here. It's 1 minus 1 plus I to the negative nth power over I. Okay? It sounds confusing, but just look at it and it'll make some sense. I is your interest rate, okay? And then N is how many years into the future. So in the cumulative discount factor, N is how far out do we want to go. So look at the same example, assuming equal cash flows. 10-year life, 12% required rate of return. What would our cumulative discount factor be? Well, here's our facts, 12%, 10 years. And all we do is plug those in, right? So 1.12 to the negative 10th is 0.32197. 1 minus 0.32197 is 0.67803. Divided by 0.12, that's our interest rate, remember, gives us our cumulative discount factor. And if you remember our problem with equal cash flows, this was our cumulative discount factor. So if we had $24,000 a year of total of equal cash flows for 10 years, to get the present value of that, the factor's 5.6502. Okay? So that's how you can do them both mathematically, equal and unequal cash flows. Or you can do it in Excel, which is what I would encourage you to do. So if we do this in Excel, there are two formulas. There's a formula for equal cash flows and there's a formula for unequal cash flows. Okay? And the formula for equal cash flows is the PV function. And the PV function takes 3 arguments: rate, number of periods, and payment. So the rate is the interest rate per period. The number of periods is the number of periods. And payment is the payment made or received each period. And in this case, period's going to be a year. So if we assume that the net income is $24,000 a year for 10 years, and that our discount rate is 10%, that our discount rate is 12%, then we would use this formula as shown in the top on the right here. PV, parentheses, and then you just specify your arguments in order. And Excel will drop down a little reminder to show you, right? So in this case, it's PV 0.12, that's our rate, 10, that's our periods, and payments, which is $24,000 in cash flows, right? Okay? So then you just put that formula in, you hit enter, and you'll get your result. I'll show you how that works, and then I'll show you how you can do it like in the bottom here, where you can actually set it up so that you can change the numbers and the calculation will change, okay? So let's go into Excel. And let's just first do the formula very simply. We can say equals PV for present value, and notice that it drops down the reminder and it tells you what it wants to know. First, it wants to know the rate. Well, that's our discount rate, which is 12% in this example. The number of periods, which in this case is the number of years, so 10 years. And then the payment per period, which in this case is the payment per year, $24,000. Okay, so close parentheses and hit enter, and you'll get our correct answer, $135,605.35. Easier than the math, easier than dragging out those crazy tables, right? The other way we can do it, and the way that I like to do it, is you can set it up so it's a formula. So we can put a few different things. Let's say rate, periods, and payment, right? And we'll say our rate is 12%, our periods are 10, our payment is $24,000. And then let's just add a value here, present value, okay? And we're gonna say present value, it's the same formula, but instead of typing the numbers into the formula, we can reference the cells. So we know that rate is here, we know that period is here, so you just click it and type a comma, and we know that payment is here, and we hit a parenthesis to close that up. So now you see it says present value, C2 is the rate, C3 is the period, C4 is the payment. Hit enter, and it gives us the right answer. The fun thing here is that we can see the numbers we're referencing, and we can change it. So maybe we decide we do need that 15% rate to compensate for increased risk. All we have to do is change this to 15%, and you can see that it recalculates our present value. Obviously, our present value goes down. It goes from $135,000 to $120,000. So that's how you do this in Excel. And that's for equal cash flows. Now we'll take a look at unequal cash flows and how you do those in Excel. Well, unequal cash flows in Excel use the NPV function, net present value function. And it accepts two types of arguments. The first argument is the rate, which is the interest rate per period. And then the rest of the string is just a list of cash outflows, inflows or outflows, right? So look at this example. We see in the yellow table our 10 years of unequal cash flows, right? Ranging from a $34,000 annual cash flow in year 1 to an $18,000 cash flow in year 10, okay? And you can see that this is from the book. They've calculated the discount factor for each year. They've gotten the present value for each year, and we see that the present value of cash flows is $144,367. Well, you don't want to have to go through and you don't want to have to go through and find the discount factor for each year and then add these up, right? So you can do this in Excel too. And you'll see an example here. It's just you type in a list of cash flows, and I've labeled them here. You don't even have to label them. You type in a list of your cash flows, and then you use this calculation. Equals NPV, open parentheses, give it your interest rate, your discount rate, comma, and then you specify your list of cash flows. And let me show you how to do that in Excel. Okay, just make your list, and I'm just gonna label them so it's easy for us. You don't want to sit here and watch me type this, so I'm actually gonna go ahead and speed this up for just a second. Okay, so there's our list of cash flows, and then all we do is use that NPV formula. And I'm just gonna label this again and say, we're gonna say equals, right? Equals NPV, and that drops down a reminder for us again, and we know that the rate we want is 12%. Make sure you convert your percent to a decimal, 12%. And then it wants a list of values. And the easiest way to do this is to click your first value, hold down, and highlight all the values, okay? When you have all the values highlighted, just type a parenthesis and hit enter. And it's gonna give you the present value. The present value is $144,367.21. Notice that if we look at our Excel calculation and our book calculation, they're both $144,367. So I'd encourage you to watch this a couple times and learn how to calculate these in Excel. It's gonna save you a lot of headache, okay? So then there's something called the Profitability Index, because when we think about proposals, especially these larger capital expenditure proposals, they're usually mutually exclusive, right? A manager's going to have to choose between projects because we don't have the money to do everything. And what you're going to be tempted to do, what I'm tempted to do, is take the one with the higher net present value, but that's not always the right answer. And so we want to calculate something called the Profitability Index. Both net present value and the Profitability Index take a look at cash flow, but net present value is giving you the dollar difference, right? and the profitability index is converting that to a ratio. So if you look at project A on this screen, it has a net present value of $18,112. Project B has a net present value of $20,574. But look at the calculations on our right. See the formula for profitability index? It's the present value of net cash flows divided by the initial investment. Okay? So for project A, $58,112 divided by $40,000 is 1.45. For project B, $110,574 divided by $90,000 is 1.23. So in this case, we'd actually want to accept project A instead of project B. And this is the reason the ratio is so important, right? The actual dollar value of the actual dollar net present value is larger for project B. But you're spending a lot more money as well. So you're actually getting a better return on your money. Your money is more profitable if you do project A. Okay, our second discounted cash flow method is the internal rate of return method. And in this method, we're trying to find the interest yield of our potential investment, or the rate of return percentage, basically, of our potential investment. And if that percentage is equal to or greater than our required rate of return, then we know that it's a good investment for us. If the internal rate of return is equal to or greater than the required rate of return, we'll accept the proposal. And if it's less than the required rate of return, we'll reject it. We'll reject the proposal. So let's look at this example with JoJo. JoJo is considering the purchase of a new front-end loader at a cost of $244,371. Net annual cash flows from this loader are going to be $100,000 a year for 3 years. Determine the annual rate of return on the loader. So if you look at this table is using the discount factor from those tables in your book. And it shows in year 1, we have net annual cash flow of $100,000, a discount factor of 0.90909 for 10%, 0.90090 at 11%, and 0.89286 at 12%. And you'll notice that it's giving us those discount factors for each year for the 3 years. And so what we're really doing is iterating over the 3 years, trying to find the right percentage. And so you'll see that at a present value of 10%, it's at a present value factor of 10%, there's a net present value of $4,315. At a net present value of 11%, the net present value is 0, and at a net present value of 12%, it's negative $4,188. So therefore, we would say that the internal rate of return on this project is 11%, because that's where net present value equals 0. Well, this is not a great way to do this, right? Pull a bunch of numbers and guess over and over again. So there's 2 ways to do it. If cash flows are equal every year, you can use a formula. So capital investment divided by net annual cash flows equals the internal rate of return factor. So in this case, cash flows are equal. They're $100,000 a year for 3 years. Well, the capital investment of $244,371 divided by 100,000 equals 2.44371. If you look at table 4 in the appendix of your book, you'll see that the discount factor for 3 periods at 11% is 2.44371. So you can find it that way. Or please do this. You can do it in Excel using a function called IRR. And IRR just takes a list of values. That's its only argument. It takes a list of values of inflows and outflows, and it gives us the internal rate of return. So you'll see an example here. I've listed the initial investment as an outflow, years 1, 2, and 3 as inflows, and then that formula gives us the internal rate of return at 11%. So let's look at doing that in Excel. Let's just do that together really quickly. We have our initial investment, and this is where internal rate of return is different than net present value. Net present value, you don't put your initial investment in here. So initial investment, and you want to put it as a negative, right? Because it's going out. And then year 1, there's 100,000 inflow. Year 2, there's 100,000 inflow. And year 3, there's 100,000 inflow, right? And then all we want to do is get our internal rate of return. So we say equals IRR is the function, and then it's going to drop down what it wants. And then what you do, click your first value, hold down, and highlight your list of values, right? You want C2 to C5 in this case. Once those are highlighted, close your parentheses and hit enter. And it'll show you that the IRR is 11%. Now, one thing that Excel is guilty of doing a lot of times is that it will cut you off. So notice that it's rounding to 11%. You can always say you want to see a couple more decimal points just to make sure that you get the right percentage. In this case, it is 11%. But it has a tendency to round when you maybe don't want it to. But it's that easy, right? You just list your cash flows, equal IRR, tell it what you want, and you'll get your result. And this is what's called an iterative calculation. And so what it's actually doing is it's pulling these discount factors and these present values, and it's trying to find the one that matches. But it does it for you instead of you doing it. Okay? So there's a little bit of math, a little bit of Excel. I really encourage you to learn Excel, but what it boils down to are these two methods: net present value, internal rate of return. Net present value is dollars, and if those dollars are greater than 0, you accept. If they're less than 0, you reject. Internal rate of return calculates the rate of return on your investment, the interest yield on your investment, and it's measured in a percentage. And if that internal rate of return is greater than or equal to your required rate of return, you accept it. If it's less than your required rate of return, you reject it. So that's that easy. The third technique is that cash payback technique, which you'll see used sometimes, but remember that the difference is cash payback technique does not consider discounted cash flows. It doesn't consider the time value of money. Net present value and internal rate of return are discounted cash flow techniques. They do consider the time value of money. So these are the two you're going to see used predominantly in practice. So that concludes our lecture on capital budgeting. You need to be very familiar with net present value and interest rate of return methods. You'll also need to be familiar with the cash payback method. The appendix to the book has the manual tables and calculations for you. I'm going to put a link out there on Canvas so you can get to discount factor tables if you want to do it that way. But I'm also going to throw together a quick sheet on how to do this in Excel. I would really encourage you to watch those components of this lecture again and really figure out how to do it in Excel. Get used to that, and that'll be a lot easier for you. And if you're mathematically inclined, you can also go back in the slides and look at the mathematical formulas and do it that way as well. So with that, I hope you have a fantastic spring break. I hope you're able to get out of town for a while. As you know, I work at the University of Tulsa now. Our spring break is this week, and it's fantastic. That's why I was a little delayed in getting my lecture up here, unfortunately. Hope you get out of town. Hope you have a wonderful vacation, and I hope that you're well. Talk with you soon. Bye-bye.